this math and physics. How do we do it? With the introduction of physics and math, not only were we able to understand better the world around us or use the knowledge to benefit us ourselves, but physics and math has impacted our society by helping us to understand nature, phenomena, and even to predict it. Yes, we know physics, we do a part of physics that studies the motion, behavior of matters, as I mentioned the other time, throughout the time. In physics, it is very important, the time, the matters, all these counts. It is the study of natural world from the microscopic, that is the smallest of everything, of a particle to the microscopic level of space. That is, physics has changed our understanding of the universe, and in doing so, it has changed our philosophy and way of life. Physics is the science that has driven our technological advances and our understanding of the universe. Without physics, we may not understand our world. And mathematics also is the study of numbers, yes. Arithmetic, the number of theory, formulas, and related structures, the algebra, shapes, space in which they are contained, that is the geometry of it, and quantity and the changes with analysis of all this. It is the understanding of all this that makes us understand it. When we now look at both of them, both mathematics and physics, they are closely related, they are connected. For physicists, mathematics is the tool that we use to answer those questions, like formulas we use. For example, Newton's inverted calculus, where God describes motion. When we say everybody moves in a similar motion on a straight line, unless being disturbed, you will continue to move. That is the first law, Newton's first law. And Newton's third law says action and reaction is equal but opposite. So for mathematicians, physics can be the source of inspiration with theoretical concepts such as general relativity and quantum theory, providing an impetus for mathematics to develop a new thing. As I said the other time, this Newton's law of motion, when you write it, you can write it in an equation. It gives you the formula to work with. So they are both working hand in hand. Mathematicians will look at the patterns and ask if the pattern is just a special case or is an indicative of something deeper and use it as proof. A logical argument shows that something is true. That is what mathematicians will do. And physicists, they will rely heavily on this mathematics for their calculation in their work. They don't work towards a fundamental. They try to understand the abstract, the mathematical ideas in the way that mathematicians will understand it or will do it. So, physics wants answer. And the way they get the answer is by doing computations. Mathematicians, the computations are just a decoration on top of cake. You have to understand everything completely. Then you do a computation. That is by mathematician to the party. That is, for you to understand a concept, you must be able to do computation of it. And that is why we want to take you through math lab for computation of your work. If you can, with this, you can easily see the pattern on which you want to work with. We have a physicist, a lady. He said, "Once we use the analogy of language, highlighting a need to translate ideas in order to make progress and understand we are dealing with how to formulate physics questions so it can be seen as a mathematician, as a mathematics problem. That is typical the hardest part. You know, in mathematics, what you usually do is you look for problems in mathematics and you try to solve it. That is how mathematician work. And if in physics, you will translate this problem they've created to provide a solution. So our environment, the physics and mathematics, you can see that they are related. Physics is helping us to understand the natural phenomena and even predict it. We see physics in all things. Everything we do daily, we see physics in it. You will be amazed that there is a Yoruba saying that says, Lala Toloke, and will it not amaze you to tell you that that is exactly what Newton's doctor action and reaction. It's not even that. Lala Toloke, that is law of gravity. Law of gravity. You can see. The other one, action and reaction is equal and opposite. There is also Yoruba saying that it's related that you can share your tó bá báyọ̀ lẹ́sẹ̀ definitely òun náà react, that person will react back. That is the physics of life. So you can see physics in everything you do. Mathematics, which is of central importance to modern society, provides the vital underpinning of the knowledge of economics. It is the essential in the physical science, technology, businesses, financial service, and many areas of ICT. It is also of growing importance in biology, medicine, and many of the social societies, social sciences. Look at us. Even if we are selling paper, we must know mathematics. If we are selling courage, you must know that if I sell 5 of this so amount, I must be able to get this. And at the end of the day, what will be my gain if I should buy this amount of orange? So you can see mathematics all around you. In your interaction with other people, in everything you do, you see mathematics there. So physics and math are needed almost everywhere, be it engineering, science, or technological disciplines. You can say science as well as technology will not exist without mathematics. You know, mathematics is the language of science. In order to analyze data, recognize certain patterns, and even proving facts, one needs to apply math. Only then you can understand the complex information. If you know the simplest of 2 plus 2, you can be assured to know when you say 2 factorial or 3 factorial. So almost every career you can see they make use of mathematics and physics. Science did it, physiologists did it, even the cashier said it. This is the reason why every student has to learn mathematics in school or in college. However, many students do not take this subject as seriously as they should. Many of them say they don't want to get jobs that involve maths. We hear this all the time, especially when you go to social science class or you go to faculty of art. I don't want to do anything related to mathematics, but lo and behold, you make use of mathematics every time. Mathematics and physics are not only subjects at school, which every student needs to study. It is much more than that. It builds the basis for many other disciplines, be it economics, computer technology, or chemistry. Hospitals also need mathematics to ensure that all their daily procedures run smoothly. Businesses and companies try to maximize their profit with the help of mathematics. mathematical concepts. And even you and I use mathematics every day. For example, when we go to the supermarket or we drive our car, we need to calculate and analyze how much fuel have I used, how far have I spent all my money in the shopping mall, how much do I have in my pocket. Above that, mathematics help us to make better decisions and to manage our everyday life. Therefore, no student should say that he or she will never use mathematics or ever again after school. But this is highly possible since we are confronted with different mathematical concepts every day. However, these concepts can help us to structure our life and manage our tasks. Thus, everybody should be grateful for this especially useful discipline. So mathematics and physics is very, very needed and should be used. We do not only need math and physics in certain career and science. It is the part of everyday life. Whether you go shopping, when you are playing your video games, you need mathematics and physics. When you are cooking your dinner, you measure your rice. You want to know the amount of oil to put. But mathematics is always everywhere. Indeed, life as we know it will not be possible without mathematics. Therefore, every student should pay attention when studying mathematics and physics in the college. Thank you. Differential equation, what are the types we have, application and example. But I will not conclude. The other colleague will conclude for us. I just want to tell us what is ordinary differential equation, what are the types of ordinary differential equation we have, and its application. When we say an equation contains only one independent variable and one or more of its derivatives with respect to the variable. What we are saying is that when you have an equation, mostly you cannot talk about the equation when nothing is dependent on another. That is, in an equation, you always have variables. Ordinary differential equation is represented as a relation of having one dependent variable. Let's say, for example, x and the real dependent variable with some derivatives. What we are saying is that, like in this case, we say that the independent variable here we say is x. That is, x does not depend. X does not depend on anything. And we say that, y say it depends on x. That is, you cannot talk of y without x. You can only describe your variable. When you talk of equation, you have to settle your variable in terms of the other. And in ordinary differential equation, you are saying that one of the variables depends on the another. That is, let's say a man and woman. I'm sorry, I want to refer to the word of God again. He said that man is created because of woman. And you don't know when God created Adam, he said it's not good for this man to be alone, but he will provide a woman for him, an helpmate. So it's like the man is like, in this case, our the variable here is x, and the dependable is y. That is, that man depends on woman. So our variable the independent variable, which is our x. The x here is independent, and that's why depend on x. Whatever the value of x is will have effect on the value of y. So the unknown function, which is we say is our dependent variable, is a function of a single independent variable. It is classified according to the order of the highest derivative of the dependent variables. That is, when you think about in respect to the other, we say our x is independent, but our y is dependent. Whatever may be the value of your x, of your y, will depend on what the value of x carries. So when you now talk about homogeneous differential equation, that is, the homogeneous in this case means that your function of x is equal to 0. When the function of your x is equal to 0, what we are saying is that whatever the value of your x is, we say x is a function, x is the function of x. We said that our y depend on x. So whatever your value of x is will determine the value of y. So when you say the function is not homogeneous, that is, the function of x must always be equal to 0. Whenever it is equal to 0, it is an homogeneous differential equation. When your x, the function is not x, your function of x. That is, what we are saying is y is equal to f of x, which we now say is 0. So the values that x carries, which y depends on, will always give you 0. And whenever you have such, that is an homogeneous differential equation. So we have different types of homogeneous differential equation. We have autonomous ordinary differential equation. We have the linear ordinary differential equation, and we have non-linear. So when you say it is autonomous ordinary differential equation, this one does not depend on variable, say f. It is known as autonomous differential equation. Any function that is its own derivatives, let's say its own solution is, we say that our y is a function of a value. So when you differentiate it, it gives you f of y. So if a solution is y of t is equal to e raised to power t2, what we are saying that the value of y depends on the variable t. So y is equal to e of x is a solution for that equation. So, and when you are talking of a linear equation, you are saying that if a differential equation can be written as a linear combination of derivative of y, then they are called linear ordinary differential equation. They can be further classified into two types: the homogeneous linear differential equation and non-homogeneous. We said the homogeneous one is when our the x is equal to 0. That is homogeneous. It's also a linear equation. But when it is not equal to 0, you have a non-homogeneous differential equation. So if the differential equation cannot be written in form of a linear combination of derivative of y, it is known as non-linear differential equation. Linearity is just from the word linearity. If it's not linear, like I will say, the y the x is equal to 0, the y dx plus, you can even have dy dx plus sin x minus cos is because they are still linear, but immediately it is not, there is no linearity in it, then it says a non-linear ordinary differential equation. It has application in so many ways. It has application in so many ways. And electricity, you can use it to describe the motion of a pendulum, and this I believe many of us did in physics 101. That is the simplest simple modulus in physics. It can be used in Newton's second law of motion, like the law of cooling. I think I mentioned the other time the Newton's first law of motion. The Newton's second law of motion, which says that the force depends on the mass and the acceleration. What we are saying is that most times life situations depend on one thing or the other. So if I want to describe that, oh, what is the if I want to describe a situation, I will look for one variable. I will say that this variable depends, what are those factors that it depends on, to be able to calculate maybe the rate of growth or something. That is why it is very useful. I mean the differential equation. If I say that x is equal to the x depends, yeah, I say x is the variable that y depends on, and I say that x growth is certain way. I can use differential equation to tell us how the situation will be in modeling of different things. So the differential equation can be used in modeling. It can be used to explain electrical circuits. We say first order differential equation arise in the modeling of electrical circuits. The L stands for the impedance of that circuit. I is the current over time, the rate of change of current plus the resistance multiplied by R will give us the electromagnetic force of that that circuit. So that is how you can use differential equation to model your electrical circuits. As I mentioned the other time about second law, Newton's second law, a body acted upon by a force, they will move in such a manner that the rate of change of momentum is equal to the force. We know that, say force, that is force is equal to MA. That is very common, I know about in physics. You must have done it in physics 101 or 102. So this describes how you can use mathematical formulas. I explained the other time that everything about life is you can put it into mathematics form or in equation form, and that is exactly that second law of motion is what we describe here. That is, the force is equal to the rate of change of momentum. Our momentum is m multiplied by v, and the rate, the time at which this momentum is changing, and we say that the force depends on it. So you use that to calculate, and at the end of the day, the v over the t, which we know is the acceleration. So that is how we conclude that the force is equal to mass and acceleration. That is, the force of the body will depend on the rate at which the body is accelerating, multiplied by its mass. It will give us the force active on the body. Not yet.